Thank you. Okay, thank you for the introduction.
You're welcome.
And I just wanted to say that I'm so proud of Omar, Ayman, and Alian for organizing this conference. You're doing an amazing job, and I love BJS conferences. So it's, yes, a huge applause for them. It's always an honor to be a part of it. So yes, today I will be talking about backend for front-end developers. And why? Because React, especially recently, is blurring the boundary between front-end and back-end more and more. And then I figured that it's now very relevant to talk about a few back-end concepts. I say a few because it's impossible to cover all of them. So it was a tough pick, but I hope that I will spark some interest to dive further after this presentation. So a few more things about me. I currently lead developer experience at HDB. And as mentioned before, I was working on Blitz.js framework. And I led the Hasura frontend team. You can find me on Twitter. Don't hesitate to reach out to me. I'm Aleksandra says there. And you can check out my personal website, aleksandra.codes. So let's start by briefly covering how we got here to this point of those boundaries between front-end and back-end being blurred. So the very crucial point in time was 2009 when JavaScript was moved outside of the browser, and it was able to use it, like we were able to use it server-side. So that opened a lot of possibilities, and we had full-stack frameworks coming up, like Meteor in 2012. Then we also saw increasing popularity of the mean stack, so Mongo, Express, Angular or alternatives, and Node.js. And then in 2016, we had Next.js. It wasn't yet a full-stack framework. It was a front-end framework. But just a few years later, they added API routes. And that marked Next as a full-stack solution. So I just started a timer, so I know that I'm not over time. So now let's take a look at the recent years. A lot happened in 2020 in the full-stack world. So a lot of that happened in those last 3-4 years was connected to Prisma, which was like the beta was introduced in 2020. And that gave us this modern type-safe approach to databases. And it would have been a shame not to leverage that and not to build on top of it. So here we go. Blitz.js in early February 2020. And it lets you import backend code into your frontend code. And the Blitz compiler makes sure that everything that is supposed to run on the server only runs on the server and nothing is leaked to the browser. And then there was Redwood in March, focusing more on the GraphQL. And around the same time, Next.js added get server-side props and get static props, allowing you to have backend logic right next to your component. It meant that you could access your database easily in the same file. And again, the code would only be executed on the server, not allowing any sensitive data to leak. Next, around December 2020, React started talking about React Server components. And later in 2021, we saw increasing popularity of TRPC and T3 stack, which was TRPC, Tailwind, and Typescript. And then we also had Remix, another full-stack solution. And in October 2022, Next.js 13 with React Server component support. And there are also other things that I don't have on this slide, like Tanstack framework, for example. And all of that moved like full-stack development forward, and all of that started blurring the boundaries between front and backend. So, like in the React world, like all of that evidently led to yeah, to the idea of having backend and frontend tightly coupled. And there are many advantages of that. Like first, we have fast iteration, no context switching. We have type safety because like with the before mentioned solutions, you don't risk losing type safety on the boundary between server and client. And especially if everything is so close to each other, or even like this in the same component, like with RSC. So this is all amazing, and you can build full stack applications easily. And in many, many cases, it's more than enough. But I still wanted to cover some backend concepts, as when your app grows, you might face problems that require different solutions. And I do wish for all of you, for your apps to grow in popularity so much that you need to reach those solutions. So let's start with an example so that we're on the same page and I have something to reference to. So I chose a ticket selling platform, and let's say you're building this app, and let's say you are like at first you're focusing on local events. So you have a small user base, it's all good. You can use, for example, Next.js, host it on Vercel, and maybe you have a few calls to the database, and that's about it. But then your app grows, and we started facing some problems, or like we started facing some, like we have more ideas about how to handle things. So the first thing you might notice is increased concurrent demand. So let's say that there are many, many users trying to buy a ticket at the same time, or maybe trying to register to your platform at the same time. So let's say, let's take this registration as an example. So when a new user joins your platform, there are a few things that you would like to do. Like you want to insert your user to the database, then you probably want to send a welcome email, maybe add them to a newsletter, and possibly also do something else. And all of those steps, all of those 4 steps, they take time. And only when all of them are completed, you send a successful response. And now, like not only it takes time, and not only you are blocking, the registration flow, but also what if something goes wrong? Like what if adding a user to a newsletter fails? So we are on this first step. It failed, and now we are like possibly somewhere there throwing an error. And the user gets a notification that the sign up was like it failed. So what probably they try to do is to try to sign up again. And then they get an error from the database that user with this email already exists. That's not cool. And this is when I want to talk to you about background jobs. So with background jobs, you can delegate a lot of these extra computations to an external process. So in this particular example, we could probably say that we want to insert user to the database, and then all of the other things, like adding to the newsletter, sending emails, or whatnot, can be done later in the background. So for all of this kind of things, I'm using something called ingest. It's like it provides with serverless queues, background jobs, workflows, lets you set up webhooks very easily. It runs on serverless, and there's like 0 infrastructure to manage. What they also handle is automatic retries, so that if something goes wrong, one of our steps, if, for example, adding to a newsletter fails the first time, then it retries automatically. So this is how this is how I would create a new function that handles the new user creation. I'm creating a new ingest client, and then I'm providing an ID of this function. I'm calling this event user/created, and then in the function body, I have all the steps that I want to cover when a new user is added to my system. And then going back to my application, to my Next.js API route, but it can be anything really. I'm just using Next.js as an example here. Instead of doing everything in a blocking way, I'm programmatically invoking ingest function, and I'm saying that the user was created. This is an email that you want to use to perform all the operations. And all of that will be done in the background. I don't have to worry about it. I can return a successful response to the user. And now I promised some TypeScript, and ingest is really great at that. So here is an example of how I would create a schema so that I have like the data that is required inferred, and I know what I have to provide to the function. So so basically, when you create a new ingest client, you can provide a schemas property. And in this case, I'm having this one event only, this user new sign up. And I'm saying that the type of it is that there's data, and the required properties are email and name. And then when I'm using this, this particular ingest client, this event type is fully inferred. And so another thing that I wanted to mention here, like that is kind of related to offloading some computations, are webhooks. So now let's say that you are using an external service for your registration, and now with webhooks we can send like information to that service that there was a sign up. But we don't have to wait for the response. We provide an endpoint to this external service, and we are like, call me back at this endpoint whenever you're ready, whenever you finish processing whatever you are supposed to process. And then in our webhook handler, we are waiting for this event from this external service, and whenever we get it, we perform any operations we need. So, I here also have an example of ingest, and it's again a function. In the event, I'm waiting for some kind of third party of service. The event is called user.created, and whenever I get it, for example, from Clark, I perform actions like sending emails. And another very cool thing coming from ingest is something called typed webhook.tools. So this is like a webhook testing tool for checking payloads with automatic type generation. So any request that is sent to this URL, the one that is generated for you in the tool, will be logged instantly for testing the HTTP request, and you can inspect the headers that you got and the body, and it also automatically generates TypeScript types, Q schemas, and JSON schemas based on the payload that the webhook endpoint got. So now another thing, let's say we're still in this ticket selling platform world. We want to send regular reminders about the events you sign up to. Or maybe we want to remind people that they still have to pay for a ticket, or maybe they set up some kind of reminders when the tickets are going to be available. So this is when cron jobs come into play. And this is a tool that originates from Unix-like operating systems, but the concept itself became ubiquitous across different platforms, and they allow you to automate repetitive tasks, and they ensure that those operations run smoothly without manual intervention. So you basically provide a config, like how often this job is supposed to run, and then it's going to be run in this particular interval. So again, an example with ingest, like let's take it step by step. The first one is this time when I'm creating a function, I'm also saying that this is a cron, the second argument, and in this example, I'm saying that it's supposed to run at noon on each Friday in the Paris time zone. Then the next step, the thing that I want to do is I want to send like a weekly digest with all the events that people sign up to, for example. So I'm mapping through all the users, and I'm creating this event object that I'm then going to use in the second function. And here I'm invoking the send event, and I'm calling it send digest events with the array that I just created. And then I have this. I think there's something missing on my slide. I should also invoke this send weekly digest somewhere there. But let's take a look at it. Here I have this send weekly digest, which is just a regular ingest function, as I was showing before. So let's also take a look at another thing. In this ticket selling platform, when someone buys a ticket, there may be different paths that the application can take. Like the payment can be successful. This is an easy path, the happy path, and we want to send an email with the tickets. But the payment can also fail. So in that case, we probably want to send a reminder email with the payment information. We may want to do this a few times, depending on our preferences. And let's say we are waiting 2 days or 3 days, and if someone doesn't pay for the ticket, then we are just releasing it. So for something like that, I'm using something called wait for event from ingest. So basically, in my function that is supposed to handle in the background all the stuff related to buying a ticket, I'm waiting for this payment completion, and whenever I get it, I send an email with the tickets, and otherwise, I know I can send reminders. And then another thing, another problem that we can face in this full stack application is that we want to maintain good user experience while we have increased demand. So let's say some tickets are only available at a given time, people are waiting for them. So the thing that they could do is just keep refreshing the page. That's one thing. But maybe we want that to be updated in real time so that they don't have to do this. Or maybe if we have a lot of people buying tickets, we want to show live indicators of how many tickets are left. So for all of that, we need some real-time features. And we need that to improve the user experience and to improve the feedback loop with how people interact with the application. So I want to talk about a few backend concepts here. So the first one is polling, and it's a technique where the client periodically requests data from the server. So let's say every few minutes you check if there were changes in the database. And it's like checking your phone for messages every few minutes. So it's not the most efficient, but polling is very easy to implement, and it can be optimized for less active data streams. And then for more dynamic bidirectional communication, we have WebSockets that they offer this persistent connection between the client and the server. And it's perfect for features that require immediate interactions like live chats or collaborative editing. And they ensure that that your users get updates in real time. So in the context of our ticketing app, we could know right away how many tickets are left based on the updates in the database. And here I want to show you an example with TRPC. So TRPC is Typescript RPC-based library. that provides type safety when creating and consuming APIs. So I'm creating this gRPC router, and I have this on-add procedure, which is a subscription. And inside, I have this helper function on-add, which emits data to the consumers. And I'm saying that whenever an action called add happens, I want to invoke it. And then I'm also unsubscribing from it with this return function. And then I also have a regular procedure add. So there I'm, for example, like when something is being added to the database, I'm adding it to the database. And then I'm also emitting this add so that the observable can catch it. And then this is how I could use it on like in a React component. I'm having here this use subscription, and like everything is inferred. Like the type of the post is inferred thanks to tRPC, and then whenever I get whenever from the backend I get a new post, I can update my local state and show it to the user. And then another like design pattern that I wanted to mention is PubSub, or like a publisher subscriber. And so when we were talking about WebSockets, we were talking about it as like the client and the server, they are aware of each other, and there's this connection between them. While with PubSub, it's more like the publisher doesn't really care about who subscribes to it. And it like the idea here is that it publishes some like data on different topics, and then like some client applications like subscribers or like even different server processes can subscribe to particular topics. That can be implemented through WebSockets, but doesn't have to. And there are tools like, for example, Google PubSub that you can use for something like that. And this particular pattern can be useful when you don't need or when you don't want this constant connection between client and server as before, and you want to send messages to many clients. And then another thing is we have this app. We already have background jobs. This is cool. We don't have that long computations blocking. And then we also have some real-time features, but we may also have even more popularity. And we don't want things like IRS website crashing on tax day because the demand was really high. So the thing that we can do here is caching. So for caching, we can, for example, use Redis or something else. And it basically means that we're kind of duplicating the data that we have on the server. We keep it close to the user. So when the user requests data, we are trying to see if it's in the cache, which is close, so the request won't take that much time. If it's there, we just return the response quickly. If it's not there, we do have to read it from the server, and we can store it in the cache. And then like when the next time when user requests the same data, it's gonna be much faster. And here is an example with Redis. So I have a few functions here. So the first one, like get cache, I'm just requesting some kind of content, like based on the key from the Redis database. I also have set function that sets the cache value for a given key with a given expiry date. And then I have a handler that can be, again, like a Next.js API handler or with another framework. And there I check my cache, and I want to see if the data with a given key is there. If not, I'm doing a fetch request and I'm updating the cache. And now, another thing that can happen when your app grows in popularity are uninvited guests. So something that is very useful here is rate limiting, which basically works this way that when it says that there are a lot of requests coming from for example, from the same API, it blocks them and limits the amount of requests that actually are reaching your server, so it's not overloaded. Here is an example with Vercel key value store and Upstash rate limit. So here I'm using this rate limit from Upstash. I'm setting like what's my key value store. I'm using the Vercel's one here. I'm also saying like what's the actual rate limit, how I want to limit it. In this case, it's 5 requests from the same API in the last 10 seconds. And then I have an Next.js middleware where I'm using this rate limit function. So this is very useful, and this is something that you probably want in your apps anyway, like even like way before they grow in popularity. Because otherwise you may deal with some increased bills from your hosting platforms. And then when we have even more popularity, there are a few other things that we can do. The first one is database pooling. So basically, like when we are in production, like the number of requests from the client instances, they can quickly scale beyond the connection limits supported by the database software. So, this is also very complicated because for the client application to open a connection to the database, there are multiple steps, like a DNS lookup, like a three-way handshake to enable TCP connection, the encryption stuff, authorization, authentication. So all of that, it's not ideal. And especially if you need to switch it and do it from scratch for different clients. So there's something like connection pooling, and it's a strategy that lets you recycle database connections for multiple requests instead of closing them immediately when a query has been resolved. Here is an example with Drizzle and with pool from the from PG library. I'm creating a new pool, and then I'm providing it to Drizzle. And this PG library handles the connection pooling for me. Another quick thing is load balancing. Sometimes all of the things that I mentioned before are not enough. So load balancing is a method of like distributing network traffic equally across of like a pool of resources, like copies of your application, and it handles like the high volume of traffic. I don't have an example in code here. This is more of an infra stuff, but I hope you can find more information about it later. So a few takeaways very briefly. So for all the things that you want to run in the background or like repetitive things, you can use ingest. For real time, you probably want to stick with WebSockets. It might be useful to enable database pooling. It's also very, very useful to enable rate limiting. And for a significant load, you can use caching and load balancing. So, so the idea behind all of this, like all of the things that I was talking about, is that you won't end up on Wikipedia like another ticket-selling platform did. And having those, issues due to a high demand is kind of a measure of success. It's, in a way, it's nice, but incorporating some solutions early can reduce your stress. And last but not least, those backend concepts matter more than ever. And the thing is that you don't have to specialize in everything. It's good to know that those tools exist and like where and when to use them. but the job is, like the developer job is about learning. So whenever you'll need them, you will learn them then. So thank you very much.